So imagine an adversary taking, maybe $500, buying a piece of plastic, a basic commercial battery, maybe a cheap camera, and just flying it right into restricted airspace.
Right.
And in response, a modern military fires a surface-to-air missile to shoot it down, a missile that costs $2 million. I mean, it really doesn't take an economics degree to see that, well, that math is exactly how empires go bankrupt.
It's completely unsustainable, yeah.
Everything is just shifting at once.
It really is. The friction between the cost of deploying these systems and then the massive cost of defending against them, it's completely tearing up the traditional aviation playbook. We're looking at this collision of forces that used to be totally separate.
We're talking everything from consumer hardware bans to $29 billion defense budgets, neighborhood drone deliveries, and even the crumbling infrastructure of human pilot training. Our mission is to connect all these dots for you. Because if you're only looking at the commercial market or, just military contracts, you're missing the invisible currents that are basically reshaping the skies above you.
Right, because the through line connecting all of this is a really severe strain on infrastructure, whether that's the actual hardware supply chain, the regulations, or even just the human operators. The tech has, it's officially outpaced our ability to manage it.
Totally.
Before we jump in, for anyone joining us for the first time, I just want to quickly say who we are. Red Raven UAS provides customized drone training, program development, and expert consulting.
At Red Raven, we work with public safety, utilities, and enterprise teams. And our focus is really on one thing, helping you launch and grow a drone program that's safe, compliant, and actually ready for your mission. We do the consulting, the strategy, and the hands-on training that turns an idea into a real operational tool.
Visit redravenuas.com for consulting, training, and FAA Part 107 certification, and check out the current special pricing on our Part 107 course.
So let's start with that supply chain and the regulatory chokehold, specifically DJI. They just did this massive hardware drop, right? 4 new products all at once. And on the surface, it's just a normal product cycle. But if you look under the hood, the U.S. regulatory environment has basically walled off this entire ecosystem.
Because the bigger picture is the FCC's covered list. It's fundamentally changed how foreign tech operates here. It targets companies whose telecom equipment is seen as an unacceptable risk to national security.
Which brings up the craziest anomaly in this whole product drop. The Osmo Pocket 4 is banned. You can't buy it in the U.S. And if you've been tracking this space, the Osmo Pocket isn't even a drone.
Oh, not at all.
It has no rotors. It's literally a handheld vlog camera on a stick. So banning a vlog camera under aviation security measures, that feels like a massive regulatory overreach. How does a handheld camera threaten national airspace?
Well, the ban isn't about aerodynamics at all, right? It's entirely about data exfiltration and radio frequencies. The covered list doesn't care if it flies or just, sits on your desk. It cares about the silicon inside. The Osmo Pocket 4 has these highly advanced Wi-Fi and Bluetooth arrays to sync with the cloud. So from a signals intelligence standpoint, any device with those specific RF chips, if it's made by a company on the covered list, it's treated as a potential node for unauthorized data routing. It's essentially a blanket quarantine on the company's entire silicon footprint.
They're just indiscriminately ripping out the nervous system of foreign-made consumer tech. But think about what that means for you. If you're running a commercial fleet, say you inspect power lines, and your main hardware supplier is suddenly banned, you have a massive problem.
A huge problem.
You can't just pivot to a U.S. alternative because, it's like banning a specific brand of smartphone and realizing we don't even make the microchips to build a replacement here at home.
That's exactly it. Building a drone isn't just about plastic and motors anymore. The real bottleneck is the flight control chip. That microprocessor that takes in, gyro data, GPS, pilot inputs thousands of times a second. For years, we completely outsourced the fabrication of those chips.
Which explains the VC frenzy right now.
Mm-hmm.
I saw Craft Ventures just gave $15 million to a startup called Hyfix. Their whole goal is just building integrated flight control chips domestically.
Mm.
But $15 million in silicon manufacturing, that's couch change. Building a fab plant costs billions.
Right, but Hyfix isn't building the actual foundries. They're designing the architecture and then partnering with allied fabs to create a secure pipeline. The really hard part for them is integration. Older flight controllers had separate chips for the IMU, the processor, the power distribution.
Right.
Hyfix is trying to mash all of that into a single localized system on a chip. It makes it lighter, more efficient, and way less vulnerable to supply chain shocks.
And the SEC is basically trying to clear the runway for this. There's this looming May 1st deadline for comments on something they're calling drone dominance.
Yeah, and that May 1st deadline is less about the hardware and more about spectrum. If you're going to launch a brand new American-made fleet of autonomous drones, they need dedicated radio frequencies, frequencies that won't get jammed by your neighbor's Wi-Fi. The FCC is trying to carve out those specific blocks.
Okay, so the commercial side is totally tangled up in this slow, bureaucratic rebuild. But then you look at the military sector, and it's like they're living in a sci-fi movie.
Oh, completely different reality.
Procurement speed is insane. AeroVironment just dropped the MAYHEM 10. And the specs on this thing, 10-pound payload capacity, 62-mile range, and it's a multi-role platform. We're talking ISR, electronic warfare, kinetic strike, and acting as a comms relay.
It's wild. The power-to-weight ratio alone is a massive engineering leap. Historically, a 10-pound drone just didn't have the battery density to run high-draw payloads, like EW jammers, while also flying for 62 miles.
So how are they doing it? Is this some secret solid-state battery breakthrough, or is it just marketing fluff? Because running a signal jammer requires huge amounts of sustained power.
It's mostly about modularity and software. The MAYHEM 10 doesn't do all of those things simultaneously. It's like a Swiss Army knife. You hot swap the payload for the mission.
Okay, that makes sense.
But the real magic is the power management algorithm. If you turn on the jammer, the software automatically tweaks the flight kinematics. It finds the absolute most aerodynamic glide path to save battery and then funnels every spare watt into the jamming array.
And while AeroVironment is doing that, the Air Force just signed a $270 million contract for completely solar-powered drones.
Mm-hmm.
But the craziest part of that source material is that they are using live combat data from Ukraine to dictate the engineering.
Which totally breaks the mold.
Right, because traditional military procurement is like a decade of committee meetings and testing. But here, are we basically seeing real-time, crowdsourced R&D? Like they pulled data from the battlefield on Monday and use it to design what the Air Force buys on Friday.
That's exactly what's happening. The old model is dead in the UAS space. The threats change weekly. A drone designed 3 years ago is useless against today's GPS spoofing. So the Air Force is treating the Ukrainian theater like an active beta test. If an adversary rolls out a new microwave jammer on Tuesday, the hardware mods and software patches are in the U.S. procurement requirements by the end of the week.
And the geopolitical shift there is massive, too. So European nations are actively trying to decouple from Asian manufacturing monopolies.
Well, they have to. Germany realizes that making drones domestically is now just as critical as making artillery shells. You can't rely on a supply chain that crosses an ocean when you're dealing with national security.
Okay, but if these platforms are solar-powered, highly autonomous, multi-role, and being pumped out everywhere, how do you actually defend against them? Which brings us back to the math of asymmetrical warfare. The Q1 2026 spending figures are terrifying. Global counter-UAS spending just hit $29 billion.
In 1 quarter.
Yes, in 3 months. If we are spending $29 billion just to swat these things out of the sky, are we losing control of the airspace?
It definitely shows how exposed critical infrastructure is. A traditional radar tuned for a fighter jet is completely blind to a 5-pound quadcopter flying below the tree line. So that $29 billion is going toward a layered defense approach because there is no single silver bullet.
And we're seeing all those layers turn on right now. The FAA and the DoD just authorized high-energy lasers on the southern U.S. border.
Which completely flips the economics. Remember that $2 million missile?
Right.
A high-energy laser is expensive to build, sure. But to fire it, it's basically just the cost of the diesel for the generator. It's pennies per shot.
Okay, but how does a laser drop a drone?
If the laser can maintain a lock for just a few seconds, what we call dwell time, the thermal energy literally melts the plastic chassis. And that exposes the lithium polymer battery to intense heat, which triggers a catastrophic thermal runaway. The drone just brains itself up from the inside.
Okay, but a laser is huge. It's a fixed base defense. You can't hand a laser to an infantry patrol.
Exactly, which is why you need the outer layers. The Marines are putting smart scope optics on standard M4 carbines right now in the Middle East. And this company, CSG, is making counter-drone ammo that you can fire from a normal rifle.
The smart scopes blew my mind. You take a basic infantry rifle and it becomes an anti-aircraft weapon. I'm assuming the optic is doing all the math.
The soldier tracks the drone, and the scope's computer vision calculates velocity, altitude, wind resistance, everything. It projects a reticle showing exactly where to shoot to hit the drone's future position. And when you pair that with CSG's ammo, which doesn't even need a direct hit, it just detonates a net or shrapnel near the drone, you have a really cheap mobile defense.
So it's basically a medieval castle. The high-energy laser is your deep moat around the base. Electronic jamming is your high stone wall. And the infantry with smart scopes are the archers dealing with the fast, localized threats.
That's a great analogy, and that works perfectly in a war zone. But the friction comes when you try to put those same high-volume flight paths into civilian airspace.
Right, because while the military sees drones as a kinetic threat, corporations see them as the ultimate logistics loophole. Amazon is targeting 30 million customers right now for same-hour delivery. They're opening massive facilities in the South Chicago suburbs. DoorDash just went live in Atlanta. But the bottleneck isn't the air traffic control software. It's what the industry calls the social license to operate. People are fighting back. Richardson, Texas is a prime example. The public is just rejecting these machines. And you're at home in Chicago or Atlanta, and suddenly Amazon and DoorDash are buzzing over your roof. Are these companies outpacing the public's willingness to actually tolerate this?
Oh, absolutely. And it's a visceral reaction to the noise. The acoustic profile of a multi-rotor drone is uniquely terrible for human psychoacoustics.
Psychoacoustics, okay.
Yeah, like a commercial jet is loud, but it's a low rumble. A delivery drone uses these tiny, fast-spinning props that make a high-pitched whine, and they hover over your yard for like a minute while dropping a package. Multiply that by hundreds of deliveries, and the ambient noise is intolerable.
Right. Getting a burrito in 20 minutes is cool, until your backyard sounds like a permanent wasp nest.
Exactly. The tech companies think it's an engineering problem. They just need quieter props. But it's a human relations problem. If a community zones you out of their airspace, your billion-dollar network is dead.
Which brings us to the final, and honestly, the most alarming bottleneck in this whole deep dive, the human element. In 2025, the FAA saw an all-time high in commercial drone test attempts. 73,914 people took the Part 107 exam. Everyone needs pilots.
The demand is explosive, but that pipeline is hiding a huge vulnerability.
Yeah, because the pass rate plummeted to an all-time low of 82.96%. So the industry is flooded with people, but the actual competency is falling apart. It sounds like we're treating commercial aviation licenses like a high school vocab test that people just cram for the night before.
That's exactly what's happening. People download a flashcard app, memorize what Class G airspace is, pass the test, and immediately forget it. Rote memorization does not equal airmanship.
And that's exactly what we preach here on the Red Raven UAS podcast. When our founders at Red Raven UAS, Derek Ward, pulling from his 35 years at the LAFD, and Michael Wilson started this, the whole philosophy was about mastering the fundamentals, not just passing a test.
Because that public safety background totally changes the perspective.
Yeah.
When you're in the fire department, your whole doctrine is risk management and situational awareness. You don't just memorize where the fire hydrant is. You have to understand the thermodynamics of the fire.
Right. Because when things fail in the sky, they fail instantly. If a pilot only knows how to push the automated return to home button and that software glitches out, suddenly you've got a 10-pound drone with a heavy payload just falling out of the sky over a neighborhood.
It makes the whole ecosystem incredibly fragile. You've got billion-dollar chips and insane hardware all being controlled by operators who literally don't have the foundational airmanship to manage a crisis.
It's wild. So if we synthesize everything we've looked at today, the drone ecosystem right now is this incredibly volatile web. You ban DJI, and suddenly we have to rebuild the entire domestic silicon market. The military skips traditional procurement to build solar-powered platforms using live Ukraine data, pushing defense spending to $29 billion a quarter just to build lasers to shoot down the exact same tech that Amazon is flying over your house.
Right, and if any one of those pillars shifts, silicon, spectrum, noise ordinances, the whole thing gets disrupted.
But the most profound shift is the one we're probably not ready for. We just talked about the human pilot bottleneck. But when you look at the MAYHEM 10 dynamically routing its own power, or Amazon automating thousands of flights, the tech is driving toward full autonomy, which leaves you with something to really mull over. As our skies become fully automated, protected by lasers, powered by the sun, will human piloting skills actually become a premium? Or are we really just training people to be system administrators, babysitting a system that's about to fly entirely by itself?
Yeah, that transition is already happening. It just comes down to how much trust we're willing to give the algorithm.
Definitely something to think about the next time you hear that high-pitched whine over your neighborhood. Understanding these massive intersecting forces is really the ultimate shortcut to staying ahead of the curve. We'll catch you next time.
Thanks for listening to the Red Raven UAS podcast. Visit redravenuas.com for consulting, training, and FAA Part 107 certification, and check out the current special pricing on our Part 107 course.